An athlete whose event is shot put releases a shot. When the shot, whose path is shown by the graph to the right, is released at an angle of 65 degrees, its height, f of x in feet, can be modeled by this equation. F of x equals negative 0.04x squared plus 2.1x plus 6.1, where x is the shot's horizontal distance in feet from the point of its release. Use this model to solve the parts and verify your answer using the graph. So we have here the graph, which is the model of the shot put's throw. So we have the shot put's horizontal distance and the shot put's height. So in part A, we want to know what is the maximum height of the shot and how far from its point of release does it occur. So we want to know that using the picture here, we can kind of estimate it, and it looks like the maximum height is going to be probably about 34 feet, and how far from its point of release it looks like to be maybe 25 feet. But we're going to be able to find the exact answers using the function that we're given here. So we have f of x equal to negative 0.04x squared plus 2.1 x plus 6.1. So because this is a quadratic function, I know that the maximum height is going to occur at the vertex. And I can use the vertex formula to find out what that horizontal distance is and also what that maximum height is. So the vertex formula will be negative b over 2a. So b is 2.1. So we'll do negative 2.1 over 2 times a, and a is negative 0.04. So we'll do 2 times negative 0.04. So that's negative 2.1 over negative 0.08. Let's grab our calculator. So using the calculator, we have negative 2.1 divided by negative 0.08. We have 26.25. So this is going to be our distance from the point of release. And then to know the height, we can substitute f, our function, represents the height. So we can substitute this 26.25 into our function to find what that maximum height is. So we want to do negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1. So let's put that in the calculator. We got negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1. We have 33.6625. and that's also feet. So for part A, our shot put reaches a maximum height of 33.6625 feet, 26.25 feet from the point of release. Okay, so I went and got part B. What is the shot's maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw? So using our picture, you can see over here that the shot would end right here, looks like in between 50 or 60. If we're going to estimate, it looks like to be about 55. But we want to find that exactly and not guessing from this picture. So we're going to solve it algebraically. And to solve it algebraically, the end of our throw here is going to be when it hits the ground. That's when the height is equal to 0. So we can find the maximum distance that the throw has by setting our function equal to 0. So we're going to solve f of x equal to 0. That's negative 0.00, excuse me, one too many 0 there, 0.4x squared plus 2.1x plus 6.1 equal to 0. And I am going to use the quadratic formula on this, but it can be a little bit challenging with these decimal values. Maybe I'll just leave it that way. I was thinking of getting rid of the decimals. Maybe I will get rid of them. So I'm going to multiply by 100 and also divide by a negative. If I multiply by 100, this becomes negative 4x squared plus 210x plus 610, and if I get rid of that negative in the front, it will be 4x squared plus 210x. Oh, that would be a minus 210x, and minus 610 equals 0. So this just makes a little bit nicer numbers in my quadratic formula. So using the quadratic formula, A is 4, B is negative 210, and C is negative 610. Got x equals negative b, that's negative 210, plus or minus the square root of negative 210 squared, minus 4 times negative 610, all over 2 times 4. So I have 210 plus or minus the square root. I need to know what 210 squared is. That's a big number, so maybe I made a bad choice here. But that's okay. So then I need to do 4 times 4 is 16 times 610, and that gives me a plus 9,760 over 8. Got 210 plus or minus, and we need to do 44,100 plus 9,760, and that gives 53,860 over 8. And I think because these numbers are not very nice, let's go ahead and just use our calculator to simplify. So I'm going to do 210 plus the square root of 53,860 divided by 8. And so we have 55, and what did it say to round to? The nearest tenth, so let's do 55.3. And there's one more x-intercept, and it just has a minus right here. So 210 minus square root of 53,860 over 8. And that's a negative value, which doesn't make sense. So really we can throw that one away. So we have a maximum horizontal distance of 55.3 feet. All right, so we have one more part, and that question is, from what height was the shot released? So I'm going to zoom out a little bit so we can see that picture that they gave us again. And based on this picture, it looks like the original height is in between 5 and 10 feet. But we can figure out what that number is exactly by letting the horizontal distance be 0. So if we do the calculation f of 0, this is going to give us the original height. So that's a negative 0.04 times 0 squared plus 2.1 times 0 plus 6.1. And we end up getting 6.1 feet as the original height of that shot. Thank you for checking out my videos. Have a great day.